We know that melanin pigment is produced in the melanocyte, so let's take a look at how that happens. Melanin production begins in the Golgi apparatus of the melanocyte, but it's completed in the melanosomes that, as we know, go through 4 stages of maturation. This melanin production is called melanogenesis. Melanogenesis is an involved and complicated process with many steps. However, we don't need to understand the entire process to get a grasp on what is happening. The production of melanin begins with the amino acid tyrosine, which is acted upon by an enzyme known as tyrosinase. This is a copper-containing enzyme. This reaction produces L-DOPA, which again is acted upon by tyrosinase to produce dopaquinone. The next reaction in the eumelanin pathway, which is one of the pathways of melanogenesis, involves dopachrome tautomerase, which used to be referred to as TRP1. The action of dopachrome tautomerase determines the difference between brown and black eumelanins in further reactions. Now that we've looked at the eumelanin pathway, let's take a look at the other pathway in melanogenesis, the pheomelanin pathway. What's interesting about these two pathways is they both begin with the same interactions, an amino acid called tyrosine. The enzyme called tyrosinase, which is the copper-containing enzyme, acts upon tyrosine to produce L-DOPA. Then tyrosinase again reacts with L-DOPA to produce dopaquinone. After that reaction, that is where things change in the pheomelanin pathway. There's a presence of cysteine, which is an amino acid, which converts to cysteine L-DOPA, and then finally through a few other reactions involving oxidation and polymerization, pheomelanin is produced. This produces the red-yellow pigments that, if dominant, lead to red or blonde hair and lighter skin tones. The key takeaways are the action of the enzyme tyrosine and the fact that pheomelanin requires the presence of cysteine amino acid.